so excited, guys. I haven't been on a live show since I can't even remember. Hi, guys. I hope you guys are doing so well. I am Looney. Tracy.
Yeah, and I'm worried about you today, but it's all right. Hello, Looney.
But you understand why I'm super excited today of all days.
Me. Hello.
Besides that, the shorty show doesn't matter. Guys, today is the 1st of July, which means it's 11 days until my birthday. What are we doing for the mindsetters today?
Well, apparently we're learning how to count. Well, mindsetters on something that's a little more important is today we're going to do mechanics revision. We're going to look at the exemplar paper from 2014. It's a really nice paper, so I hope you're with us. Now remember, mechanics means that we're looking at vertical projectile motion, we're looking at momentum, impulse, work, power, and energy, okay, and Newton's laws from grade 11. Okay, so some of that's going to be a bit revision-y. Hopefully you've done some already. Yeah.
All right, mindsetters is quite a lot. I need to tell you guys. So first things first, how to get a hold of us on Facebook, facebook.com/learnextra. And then our Twitter handle is @learnextra. And then you can get all the winter school links, all the schedules, and all the information you need to know on learn.mindset.co.za. You click on Learn Extra, you go down to revision, click on winter school, you'll get all your information there, all the notes and the videos. And then, if you're watching yesterday's shows, you might have heard Abram telling you, and Lloyd, telling you about the winter school competition that we have going on. So how it works is that all you need to do is go to Curio. There is a link on our Facebook page. The code is LEARN, LEARN in capital letters. But everything, if you click on the link, it will take you straight to the Curio page, and then you choose your team from the World Cup. So the teams that are for today is Argentina, Belgium, Switzerland, and the USA. Pick a team, and then you submit your entry. Then you go to Facebook. What you do on Facebook is that there's graphics on our Facebook page of all the teams. You get all your friends to like your favorite team. So say, for example, I like USA. Tracy?
I'm going to go with Belgium, actually.
Belgium.
We'll go with some minnows.
So we'll see who's going to win at the end of the day.
So.
Okay, cool. So you get all your friends to like your team, and then the team with the most likes by 3:30 today, all those people who entered USA, Belgium, Argentina, or Switzerland, you will get a chance to be in a final draw, and then you'll be in that lucky draw, and then a winner will be taken out, but then that winner will be taken to the end of the week, and then the end of the week you stand a chance to win an Intel tablet. Hope it's
very nice.
Did I explain it properly?
I think so.
Yeah, I hope you guys understand. It's quite a lot, but everything is on Facebook. If you don't understand, check out our Facebook page, and all the information about the competition is there.
Excellent. Okay. Of course, we're quite sad today because there are no more African teams in the World Cup, which is actually very sad. Nigeria and Algeria, unfortunately, got beaten last night, which is even worse. But that's okay. I think they've done really well. Got some new history makers in the books because of it. But now we need to focus. At least we don't have to worry about watching the games now. So, guys, the reruns, switch them off. Okay, now we're going to go on to the mechanics revision. Now, I have a challenge question for you. So, something I want you to look at. Okay, so here's the challenge question. So, a force of 200 newtons is required to pull two blocks, A and B, with masses 5 kilograms and 10 kilograms respectively in an upward direction. Ignore the friction of the pulley. Now, that's quite important because that would be an extra force. I need you to do two things, okay? Number one, I want you to determine the acceleration of the blocks, okay? Number two, you are going to determine the force Ft in the cable between the blocks, okay? So the blocks are being pulled upwards, 200 newtons, 5 and 10 kilograms, okay? Ft sits between block A and block B. I want to know what is the acceleration of those blocks, and I want to know what Ft is, okay? So this is quite a long show, so you've got some time to work on it, okay? I am going to give you a little bit of a hint. This is from grade 11, okay? And I've chosen it specifically because this is a tough one, okay? This is a tough Newton's second law question, okay? So while you're pondering on that, let's actually jump right into our first question. As I said, these are taken from the exemplar paper 2014, which is a great paper actually. It gives you a nice idea of where we're going and what to expect at the end of the year, because of course things are new. And remember, grade 12s, that they can very specifically, and this one is grade 11 work, ask you Newton's laws, applications of Newton's laws, and Newton's law of universal gravitation. Okay, now you're probably not going to do, unless your teacher's really, really good and really, really fast, you're probably not going to get to do much revision in class time of your grade 11 work. So you need to take out your grade 11 books, you need to go pass through your grade 11 exams, go through your grade 11 stuff. Guys, I promise you they're going to ask it, and it's not going to be just in between, like maybe the law here and there. They can ask you very specific questions on it, okay? So make sure you revise Newton's laws. It's very important. So they tell you a light inelastic string connects two objects of mass 6 kilograms and 3 kilograms respectively. Now, there's a couple of things we need to take into consideration, all right? They tell me that it is a light inelastic string. Light tells me I can ignore the mass of the string. It doesn't actually matter. Inelastic simply means that it's not going to stretch. Okay, it's going to stay whatever length it is. They've pulled up an incline that makes an angle of 30 degrees to the horizontal, and I can already hear the groans. And it pulls up with a force of F. Now, the first thing they tell you is to ignore the mass of the string. We go, yay, we like that. It makes life a little bit easier. Then they say to me the coefficient of kinetic friction, so that means when the blocks are moving, between the 3 kilogram object and the 6 kilogram object is 0,1 and 0,2 respectively. So my mu k over here is 0,1, and I'm going to write it in, and mu k for the 6 is 0,2. Now, guys, please don't now go, but why? How can it be different when it's on the same surface? Well, they didn't tell me that the blocks are made out of the same material. Okay, they haven't told me whether the force of friction experienced by both blocks is exactly the same. So of course mu k can change, because remember your coefficient of friction is determined on the two objects. It's determined by the two objects that are in contact with each other. So it's okay that it's 0,1 and 0,2. We're not going to worry about that. Okay. First thing they ask you to do is state Newton's second law in words. Okay? You need to state Newton's second law in words. Please be careful. Newton's second law as an equation is this one, which you learned last year. F net equals ma. Now, in words, all right, and now my matrics and my grade 11s have just written June exams. I'm sure you did as well. And one of the questions we asked them was to state Newton's law in words, second law. And the same thing tends to happen, is that you look at this and you go, F net is the important one. So you start talking about F being directly proportional to M and A, and you just get yourself completely in the tiz. Please, 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 please be careful here, okay? Now, to state in words, first thing you need to tell me is that when a net or a resultant force is applied to an object, the object will accelerate in the direction of that net force, okay? Newton's second law's got to do with acceleration. So the first part of this definition, and it's a long one unfortunately, is that an object will accelerate in the direction of the net or resultant force, number one. This acceleration is directly proportional to the net or resultant force and inversely proportional to the mass, okay? You cannot tell me that the mass is inversely proportional to the acceleration, because the mass doesn't depend on the acceleration. The acceleration depends on the mass, okay? So be careful how you write this. So an object will accelerate in the direction of the net or the resultant force. That acceleration will be directly proportional to the net or the applied force and inversely proportional to the mass of the object, okay? You could also state, instead of doing it that way around, you can also do Newton's second law in terms of momentum. They didn't really state which way. First of all, still, object will accelerate in the direction of the net or resultant force, but the net force is equal to the rate of change of momentum. Not the best way to state it, though. Okay, now, How will the coefficient of friction be affected if the angle between the incline and the horizontal increases? So what they're saying to you here is they go, well, what if I change this diagram and do this? And, sorry, that's not going to be 30 degrees. Ooh, wrong way. That's not what I wanted. It's not going to be 30 degrees anymore. Let's say we change this and we say, fine, we're going to change it. We change the angle and we make that 45 degrees. What happens to the coefficient of friction? Look at the question carefully, because for a lot of you, you're not going to go, oh wait, the angle increases, that means the normal's going to change and the force, it's got nothing to do with that, okay? Yes, friction will absolutely change, okay? Because remember, kinetic friction is mu k times the normal force, okay? By changing the incline, you're absolutely changing the normal force, without a doubt. But does that affect the coefficient? Not at all. Because like I said to you earlier, about the fact that the coefficients were different, is the coefficient of friction is determined by the two objects. So it's determined by the two surfaces that are in contact with each other, not with the direction, how much contact they have. That's not determined by the incline, it's not determined by the normal, it's not determined by the force applied. It's simply determined by the objects. Which means if I'm not changing the objects, I'm not changing the 3 and 6, I'm simply changing the incline, the coefficient of kinetic friction won't change either. So my answer to my next one is that it remains the same, okay? Nice thing here is they did not ask you to explain it. Grade 12s, as an exam tip, because I know what happens is you tend to want to explain everything, or you start to write down your reasoning because you're thinking through what you're doing. Please don't do that. It's only worth 1 mark. They only want to see the answer. If you need to write to think through things because you can't talk through it, okay, because you're not allowed to talk in your exam, do it on your question paper, okay? Write through what you need to. Even as you look at the way I do this, can you see I write all over my diagram? Do that on your question paper, guys. Your question paper is yours. Do what you like to. Write what you need to in here, and then only write your final answers on your answer sheet, okay? Then, now they say to you, draw a labeled free body diagram indicating the forces acting on the 6 kilogram object as it moves up the inclined plane. So, 6 kilogram object, that's this one, okay? F is not directly in contact with it, only the tension in the rope is, which I'm going to call Ft, okay? What you need to recognize, there's a coefficient of friction, which means friction's going to act down, and then there's going to be gravity, and of course we're going to have the normal. Guys, all the purple that I've drawn here, if I take it exactly like this, this is a force diagram. Free body diagram means that I start with a dot, okay? Free body diagram says I start with a dot. All the forces must act away from the dot, okay? So we know that there was one acting down, which was gravity. You are doing this, remember my diagram was an incline, that's just horrific, okay, was at an incline, which means the force pulling it up is in that direction, friction, which pulls this way, and the normal force goes up at an angle, okay? And these two should actually be at 90 degrees to each other, just so you remember that, okay? Now, they wanted it labeled. Labeled means I can't just write FT, FG, whatever the case may be. Label it properly. So this one was FG, which is weight, okay? If you want to call it FG, whatever, little w, then write a key down the side so they know exactly which ones they are. This is the tension force, okay? It's the tension force. It's the tension between the two blocks. Okay, this was your normal, and that's friction. Now, I know I've got to write out the words grade 12s because they said a fully labeled force diagram. I know it's only worth 4 marks, but you don't get any marks if you don't have the labels. Okay, so the mark here is allocated to, and so you got to get 3 things right to get the 1 mark. You got to have the label, the arrow, and the direction right. Okay, that gives you that full mark. Please don't put components onto this diagram. Just draw it as it is. Okay, and I think before we go into the next part of this question, because there's one more thing we need to do here, we're going to take a short break and then we'll come back and finish it.
Yes.
Yeah.
What's your team again?
Belgium.
Belgium. It's on 253
Ah,
likes.
go Belgium.
No, wait.
Oh, no, shh.
Argentina is on 685.
Argentina.
Switzerland is on 208. And my team is on 437, USA.
Yeah, Argentina is because of Lionel Messi, who might not be playing tonight, guys. Just so you know, I know more than you think. Belgium's a good team.
Don't hate.
I'm not hating, I'm just
Ask
saying.
people to vote for your team.
Vote for Belgium! Hello, vote for Belgium! Sorry.
Mindset is please get all your friends to jump on our Facebook page. Get to liking. Like all the teams that you think are going to win, okay? So like the teams, guys. If your team is Switzerland, make sure all your friends liking Switzerland. And the information about the competition is on our Facebook page. Get all your friends to follow that link to choose a favorite team and then hop onto Facebook and like. And with all of that said, let's take a very quick break and we'll see you straight after this. Welcome back, guys, from the break. I hope you are enjoying the physical sciences lesson. I'm not going to waste any more of your time. Tracy.
Oh, thank you.
Yes.
That's so sweet of you. We're all voting for Belgium right now.
No, USA. Come on.
No. Yes, no, they win everything. Anyway, doesn't matter. So, okay, let's go on to the next part of this question, all right? Now they say to you, okay, the tension in the string, well, you have to calculate the tension. I left out that. There we go. If the system accelerates up the inclined plane at 4 meters per second squared. Okay, so now remember, so I want FT, it's what I'm going to call it, it's going to be easier. They're telling me that my acceleration up here is, what do they say, 4 meters per second squared, so that's great. And now we look at this and we go, well, your first thought should be, okay, when you see a question like this is Newton's second law. Okay, where you have 2 blocks together, and perhaps we're going to have to do a simultaneous equation. But let's first think about what we've got here, okay? Because I want Ft. I know the acceleration. That is actually going to make our lives really, really, really easy. I don't want to work with this 3 kilogram, okay? Simply because, well, number one, they ask me what is F later on, so that's the first thing. But also, I don't know F. So if I consider the 3 kilogram block, I don't really know enough information about it. But in the question before, they asked me to look at the 6 kilogram block. The question before said, draw a free body diagram. So they said to me, what are the forces acting on this block? This was your hint that perhaps I need to use the 6 kilogram block, okay? So now we're going to go, okay, well, they told me to state Newton's second law. That means I'm probably going to have to use it. And Newton's second law says to me that F net equals ma. I'm now dealing with vectors, which means I need to choose a direction as positive, and I'm going to go up the slope is positive, okay? Which means my acceleration is positive, my tension is positive, okay? Friction will be negative if I add it in. So now we look back at my 6 kilogram block and go, okay, I know A, that's fine. I know M, that's brilliant. I want Ft. Now, the net force on that 6 kilogram block is going to be my tension minus friction, okay? Which is equal to ma. So now we say to ourselves, okay, can I work out friction? Absolutely. How do I work out friction? Well, my kinetic friction is mu k times n. N is my normal force, mu k, which we said earlier was 0,2. We're getting somewhere. That means I need the normal force. Okay, do you see where I'm going with this? Now we go, okay, well, the normal force is the force that's perpendicular to the slope. The normal force, if it was on a flat slope, would be equal to Fg. Can't be Fg because Fg is at an angle, which means it's got to be the perpendicular component of the slope of Fg, okay? Now, guys, I'm going to show you how I draw this triangle. Your teachers might have taught you something different, and in fact, within my own school, myself and one of my colleagues, we teach this differently. We just show that triangle differently. It's the same thing, okay? You're going to get to the same answer. So if I consider that 6 kilogram block, okay, so over here, I just want to take some stuff out so I can make it a bit easier. So here's the Fg, okay? Now what I do is I go, well, there's my perpendicular component, there's my parallel component, okay? That's what my triangle would look like. So that's Fg parallel, that's Fg perpendicular, okay? Fg is its weight, okay? That angle there is the same as that 30, so it's 30 degrees, okay? Why am I doing this? Because if I know Fg, which I can work out from its mass, and this is the adjacent side, I'm going to have to use cos. So we're going to need to use some trig in this one, okay? I use the triangle because it helps me remember whether I use sine, cos, or tan, heaven forbid, okay? Because it makes it easier for me. So my normal force is equal to my Fg perpendicular force, okay? Now watch what we're going to do. So this here, okay, that's Fg perpendicular. All right, I'm going to put this all in one equation in a second. So mu k, Fg perpendicular we just said was Fg cos theta, and Fg we know because we've done this hundreds of times is mass times gravity times cos theta. Okay? Now, what I'm going to do, grade 12s, and you are welcome to work all of these little bits and pieces out separately and then substitute them in. Okay? But I don't really want to do that because I want to try and make as few carry down errors as I possibly can. So Ft, I don't know. That's actually what I'm asked to find. Minus, now watch, it's going to be mu k, okay, times mg. Okay, and I've realized I've made a mistake. I'm hoping somebody is screaming at the screen right now, and possibly it's John in the room next door going, What have I left out here, guys? Has anybody screamed on the Facebook page?
I'm trying to check.
Okay. Now I've drawn this diagram. Look what I've actually forgotten. Okay, now look carefully. I considered Ft, brilliant. I considered friction. What haven't I considered? Gravity. I've forgotten to put in gravity because gravity also acts down. So, in fact, Ft has to overcome friction and gravity. So, over here, what needs to happen over here is this also needs to be Fg parallel, which I'm going to minus. Did anyone notice? No? Are we awake yet?
Hopefully
Probably not.
What's the time?
Yeah,
25 past 11.
Yeah, it's not early enough yet, I agree. Okay, so cos theta, and I'm still going to run out of space. So, now, over here, if I used cos for my perpendicular, then I'm going to use sine for my parallel, okay? So, over here, this becomes mg sine theta equal to ma. I don't want to get that confused. I never leave myself enough space on these things. Okay, so mg sine theta. Okay, now we can just put some substitution in. So that's ft. Mu k was 0,2. Okay, m is 6. G is 9,8. We're using cos 30. Okay, then we're going to go 6 times 9,8 times sine 30. I'm going to have to quickly rub something out so that I can actually fit this in here. Wow. I need lessons on how to write more neatly. Don't say anything, Looney.
No, no judgment.
Uh-huh.
Shorty's club.
I can hear it. Careful. I can hear it. Okay. All right. Hopefully some of you go, no, my teacher writes worse than you.
No, but your writing is fine, hey?
My
There's
kids
nothing
all go,
wrong
no,
with your
man, you
writing.
do write like that because you are my teacher. Anyway, so M is 6, and they told you that A was 4. Okay, we've done the science, by the way. Now, it's all maths, okay? So now it's a case of now we take out our calculators, okay, wasn't actually opened, and we use the black.
Which one's the calculator?
This one.
There you go.
That was my right. Yeah, that looks right. It's fine.
Yeah.
Anyway, so sorry. My director's talking into my ear and he thinks I don't know my right from my left. That's just rude. Some days I don't. I do agree with him. Anyway, so ft. Okay. And we're going to do 0,2. Oh, the ink thingy's on.
Yeah, you need to unlock that thingy.
Hey, turn off, go away. There we go. 0.2. See, it's important to talk to technical equipment, just so you know. Times 6 times 9,8 times cos 30. And we get, I'm just going to write it in because it's going to make life easier. 10,18. Okay. And then we've got 6 times 9,8 times sine 30, which gives me, remember we can't use it as a fraction, please don't do that, which is 29,4, and that's equal to 24. And when we take it all over, because remember right now what will happen is I will take the 24, okay, and I'm going to add the 10,18. Okay, and I'm going to add the 29,4 because they were minuses. And so we end up with 63,58. Okay? Did we get 63,58? Yeah, that's what we end up with. Okay? 63,58 newtons. So that's the tension. Okay, now that was worth how many marks? Let's just have a look. 5 marks. That's a lot of work for 5 marks. Okay? Take your time. Make sure you get all the bits and pieces, okay? And re-look at what you've got. Why was this important? Because what they actually do now is they say calculate the magnitude of F if the system moves up the incline. Now watch here very carefully at constant velocity, okay? Constant velocity. Now we've got an interesting, now we've got to think about this. And we go, okay, constant velocity, here it's accelerating. Ft is going to have changed, okay? Possibly. Constant velocity means that A equals 0, okay? A equals 0. You all happy with me so far? Okay. I'm just quickly checking my answer so I explain this correctly to you. Now, what we need to consider here, okay, is that at constant velocity, all the forces acting on my little object end up being equal, okay? So A equals 0. So that means when I look at this, and I'm going to, and I suddenly myself in that space again, F net equals 0, okay? F net equals 0. My F net here, okay, means that my force applied equals the force pulling it down, which is Ft, okay, and it's got gravity, okay? But now I've got to look at something very carefully here, okay? Ft is actually going to be equal to friction and my parallel force and my 6 kilogram force. Why am I saying that? Because if the 3 kilogram is going at 0, okay, if the 3 kilogram has an acceleration of 0, then the 6 kilogram has an acceleration of 0. Okay? They're equal, which means all the forces on the FT are the same. Okay? On the 6 kilogram are equal. So now watch what we're going to do here. Okay? That means force F, okay, minus my tension, minus the gravitational force, which will pull the 3 kilogram down, is equal to 0. Okay? Oh, wait, I haven't minused friction from this one yet. Whoops. Wow, I'm doing well today. Let's do, that's for the 3 kilogram, minus Fg parallel. That must be equal to 0. We're all okay so far. Ft, okay, now watch, I just explained it to you. Ft is equal to, not that, because that's horrific. Okay. The 6 kilogram friction plus the 6 kilograms parallel force down. Okay? This is just going to get ugly. Okay, so what I'm actually going to do is I'm going to do it at the bottom because I'm going to run out of space. Okay. And I think what we're going to do is maybe,
Break time.
let's take a break. And I know I've broken this up into 3 bits, but let's take a quick break so you guys can mull over that, and then we'll do it in the next one, because this is quite an important question that we get. Okay, so let's take a break.
All right.
Yeah.
Mindsetters, go think about that question that Tracy has given you. Think about it, let it sit in your mind, try to work it out, and we'll see you straight after this break to go through the rest of the question. Welcome back, guys, from that break. I see some of you are having problems with question 1.4. So because I'm kind, I'll ask the question now because Tracy's working through the question, right? Okay. This one is from Gando Sheboz. Wow. How do you know when to use FG parallel when working with FNet?
Okay. What you need to look at, and this is how I know I've got to use FG parallels. If we look at our diagram again, which right now is just full of lines, but that's besides the point. Remember, we always want to have forces that are in the same plane, okay? So because I was looking at all the forces that act up and down the slope, okay, and I'm looking for Fnet because it's got to be in the direction that it's accelerating, which is up the slope, and FG parallel works with the plane of the slope. Okay, so if I was looking at whether the objects were saying we're being pulled off the slope, then I would use FG perpendicular. Okay, so FG perpendicular only really helps us with the normal. FG parallel is with the forces that are in the same plane. They're parallel to the acceleration. Okay, so it's got to depend on which way it's accelerating. It's the same when we get to the work energy principle. Okay, which we are going to get to later on today, hopefully, if we get through this question first. Hopefully
I think Sanelisa was also asking the question because she's also asking where did we get the net force, so you just answered that.
The net force, remember net force is if I took all the forces acting in an object and I took them away and replaced them with one single force that does exactly the same thing, what would that force be? That's your net force. Okay, that's why I'm minus something, so anything pulling backwards gets minus, anything pulling up gets added. Okay, cool. All right. Thanks. So that brings me back to this one where we want F, and we realize FT is pulling backwards. Okay, remember FT on the 3 kilogram is moving backwards, and my FT is equal to FK of the 6 kilogram, and my FG parallel of my 6 kilogram. Okay, so now I've actually done it over here, and I've made it, I'm making it look, just so it looks different, so we can see the difference in the colors. Okay, so basically what's going to happen here, okay, is F, remember this is 0. It's going at 0, constant velocity, so that becomes 0, okay? So let's just make our lives a little bit easier, which means I'm going to take F becomes Ft plus my Fg parallel of the 3 kilogram plus the 3 kilograms kinetic friction. Okay? So Ft over here is this one. That's from my 6 kilogram. All right? So that means that's Fk of my 6 kilogram plus Fg of my 6 kilogram parallel. I just want to remind myself which ones I'm using here. Plus Fg parallel of the 3 kilogram plus Fk of my 3 kilogram. And now it just gets horrible because now we're going to put sign and cos and all the rest of it in. So, UK for the 6 kilogram means that I've got to use the perpendicular force of the 6 kilogram, which over here, that's the formula that we used. Okay, I've already worked that out once. It was 10,8. That's not going to change. I do not have to work that out again, grade 12s. Okay, so please don't go work that out again. Also, you do not need to work out the 10,8 and the 29,4. You've already done it. That hasn't changed. Okay, that has not changed. Please don't go and work it out again. So it's 10,18 and 29,4. So this is 10,18 plus 29, what was it? 14? What did we get? I can't remember. No, just 29,4. Brilliant. Okay, don't work it out again. If you made a mistake working it out in the first one, they'll carry it down into this question, so don't stress, okay? Fg for the 3 kilograms, so Fg parallel, that means I'm going to use sine. It's the opposite. So this is mg sine 30. Okay. For the 3 kilogram, they told me that mu k was 0,1. Okay, so that's 0, let me just first do it this way. So we're going to do mu k, my normal force. Okay, and what I'm actually going to do straight away, instead of putting my normal in there, I'm going to write that I realize that that means this is mg cos 30 degrees. Okay, and so we have 10,18 plus 29,4 plus 3, because now I'm looking at the 3 kilogram, 9,8. I should lift up my pen before I write. This was 0,1. This was 3. It's 9,8 times cos 30 degrees. 10,8 plus 29,4. Now we take out our calculator. We love our calculators. Let's put that over here. Okay, so we've got 3 times 9,8 times sine 30 gives me 13,95. And 0.1, not plus, times, because that won't do anything, times 3.8 times cos 30 equals 2,55. And I'm afraid I can't do this one in my head. So we're going to go 10,18. No, 10.18. Don't try and use your calculator too fast, because then you make mistakes. 29.4. 13.95. 0.95 plus 2,55. And we get 56,08. And we are done. And we sigh a big sigh of relief.
Oh, man.
Because that was mean. Okay, this was mean. Okay, grade 12s. If some of you are looking and going, that was horrible. Okay, this was a difficult question, grade 12s. Okay, so please don't get too freaked out. What I think it does mean for some of you, however, is that now you realize you need to go and look back again on components of objects on a slope and your friction, okay, and how to use kinetic and static friction. Are there any more questions coming through on 1.4 before we move on? Okay.
It was just those two.
Just those two. And those, those are good questions, because it's going to come up again when we do the work energy theorem. Oh, wait, I forgot I had a question. What am I doing? All right. Before we move on. Now, how would the tension in the string calculated in 1.4.1 be affected if this system accelerates up a frictionless incline plane at 4 meters per second squared? Would it increase, decrease, remains the same? Now, if it's a frictionless incline, guys, what that means here is that straight away, this value, that Fk disappears, which naturally you can see Ft gets smaller because this value that we put in there disappears. Okay? So your excuse me, Ft decreases because there's less force for it to overcome. Doesn't need to be as big. Okay? Because now it doesn't have to compensate for friction and gravity, it's just compensating for gravity. Okay? So my answer to 1.4.1 is that it would decrease. Okay? Decreases. Now we can move on. Now to the one you all hate.
And you smile.
I know, I say with such a smile because I know my learners look at me and go, we hate you, man. When I say this, I like this section. Anyway, I like bouncing balls because they're really not as difficult as they look, okay? So, they tell you a ball of mass, 0.5 kilograms, is projected vertically downwards. All that means is that it is thrown, okay? Projected simply means it is thrown down towards the ground from a height of 1.8 at a velocity of 2. So that means my initial velocity is 2 meters per second, okay? The position time graph for the motion of the ball is shown below. So watch here, guys. This is so important that you get this. Your graph is giving you your sign convention, okay? Remember, whenever you do these questions, you have to make a decision as to whether up is positive or down is positive, okay? Now watch what they're doing. It is thrown from a height of 1.8. When it hits the floor, it is at 0. When it is above the floor, it is 1.8 meters above the floor, okay? They are telling you that up is your positive direction, okay? If down was my positive direction, my graph would have had to start at 0, okay? My graph would have had to start from 0 and and it would sort of be an inverse of what we've got here, okay? Up is my positive direction. You have to use it as your positive direction. You cannot change that, okay? Now they say, first question, what is the maximum vertical height reached by the ball after the second bounce? Okay, drop, first bounce, goes up, second bounce, maximum height, 0.5 meters, okay? Not 0.9. That is not a bounce. The 1.8 is where it starts from, so where I throw it from, okay? So it's got to hit the floor and come back up for it to have bounced, okay? So after the second bounce, 0.5 meters, easy, okay? Read off the graph, and it's got to be as easy as that. It's only 1 mark, okay? Then, calculate. Now we all start. Yeah. Look, Looney's laughing at me. That's very rude.
Because you were like, ooh, and then I was like 5 marks because I knew it's going to be.
Yeah, well, 5 marks. Not that bad. Okay. Calculate the magnitude of the time indicated on the graph. So now they're saying to you, T1. In other words, how long does it take to hit the ground? That's all they're asking you. From 0 to T1, how long does it take to the ground? So, now we go. Okay. What do I know? Whenever we do an equations of motion question, write down what we know. Okay, I'm taking up as positive, okay, because that's important. We always deal with these values. Okay. I know VI, but VI, we said it's been thrown, so, and they said it's been thrown at, what did they say it was being thrown at? 2 meters per second, so VI is -2, okay. A is the same, it's vertical motion, but it's gravity, so that's -9,8. And I know that Y is it's actually -1,8 meters. We're not doing so well because it's all negative. Okay, now we need to find T. We can absolutely go this route, okay, which says that delta Y equals VI delta T plus a half A delta T squared. You absolutely can go this route, grade 12s. I'm going to suggest, though, unless your maths is very, very, very strong, okay, and you can remember the quadratic function, okay, which means for finding roots, you use minus b equals plus or minus square root of a squared minus, you see, even I can't remember.
And I'm looking at you like, what is it again?
Yeah, it's minus b plus or minus a squared minus 4ac over 2a. So I can't remember
Plus or
it.
minus b minus b.
Yeah, that one.
Minus 2a. No, 4ac over 2a.
Something like that.
Something.
Okay, can you see why we don't want to go this route, guys? And I used to be a maths teacher. Seriously, if you can't remember that quadratic function, you are just going to get yourself into trouble, okay? You are welcome to do it. But I don't want to go that route because I would imagine, and I'm thinking of my own learners as well, that there's a lot of you who are going, yeah, don't do it, okay? Because you don't need to. What we can do, okay, is if I can work out VF, I can work out time, okay? Because remember, we have an equation that says to us that VF squared equals VI squared plus 2A delta Y. Okay, and we have another one that says to us that VF equals VI plus A delta T. Okay, so if I can get VF, I can find out delta T. Okay, so I'm going to go VF squared equals VI squared plus 2A delta Y. Okay, where VI is -2. Ooh, and I'm just adding a whole bunch of extra nice, beautiful lines just because I can. And this was plus 2A delta Y. Okay, so we're going to go -2. Don't forget to put the minus in. -9,8 minus 1,8. And this gives me 39,28, but that's V squared. I want V squared, I want V. So I square root it, and we get 6. Let's make it so you can actually see it. And I'm actually going to make it -6,27. Why am I making it -6,27? Because I know that it sits in the floor and down is negative. Okay? Now I'm just going to, I really have to learn to give myself more space. Really have to learn to give myself more space. Okay, from here I can go VF equals VI plus A delta T. That's -6,27 minus 2 minus 9,8. Okay, so when that goes over, -4,27, and if you don't put all your negatives in, your answer ends up doing all sorts of weird and wonderful things here, okay? So be careful. So delta T works out to be 0,44 seconds. It's tiny. If you can use the quadratic function, go ahead, okay? Maybe take this down and maybe as just something on your own, go ahead and do it using the quadratic function. But unless you know that function, which has just completely eluded me today, please go ahead and use it, okay? Because it's minus b plus or minus b squared minus 4ac over 2a.
Yes.
See, it's come back. Takes me a while. All right, and I think on that note, because I think I'm the one who needs the break, we'll take a quick break and then we'll be back.
Oh, man. Tracy needs some water, guys. And she needs a bit of cooling off, so I'm sure she's going to splash herself with water like those players. But anyway, if you wanted to know, Argentina actually is leading, just by the way. So if you are Team Argentina, well done to you. But guys, USA, Belgium, Switzerland, where are you guys? Start voting for your teams, and all the information is on our Facebook page, so it's quite easy for you to access. We've made links for the graphics on our Facebook page as well, so everything is on top of our Facebook page. You go to the Curio link, you enter, you fill in the team that you want to win, then you go to the Facebook page and you get your friends to like that post. Argentina, Mandla, you said Argentina is leading. But let's take a very quick break. Hopefully our teams are going to start leading after the break, but we'll see you straight after this. Welcome back, guys, from that break. I hope you're enjoying this winter school revision lesson with Tracy and Looney. Tracy.
Yes, it's me again. Okay.
Yes,
all right.
yes,
So,
yes.
yeah, she's been a bit of a snooty girl right now. Okay, she went to an all-girls school, can I say? Anyway, so now they say to us, so we've got that, we're all happy, and now they go, calculate the velocity with which the ball rebounds from the ground during the first bounce. So now we've got to go and we say, well, that looks exciting. I don't know anything about forces. I know that it took 0.44 seconds to hit the ground. But you see there's a difference in time between T1 and T2. That's because it spends time on the ground, okay? But now they want to know, what is this velocity over here? So now we go, okay, well, what's the velocity when it gets to the top of its first bounce? I can hear it. Can you hear the shots of...
Yeah, I think I...
What are they shouting? She doesn't actually know. 0.
0.
Zero, there we go, okay.
Of course.
Yeah. I think she needs more sleep. Anyway, why am I telling you 0? Because remember, it's going to come bounce up. I'm not catching it, but before it can go back down, it's like when I throw a ball up in the air, velocity is 0. So what I do know about that second bounce is it gets to a height, okay? So what I know here, and once again I do this, and also, guys, your sign convention cannot change, okay? Up is positive and up stays positive. My final velocity here is 0. I don't know what that VI is. Acceleration is minus 9,8. I don't know the time, but I know that it goes 0.9 meters. Okay, so now I want VI. This one's actually quite nice, plus it's only 4 marks, so it's easy. VF equals VI plus 2A delta Y. VF is 0, and that should be VI squared. And VI is what I'm looking for, plus 2 times minus 9,8 times 0.9. Okay, so my VF squared ends up being 17,64. Now, if you've made a mistake with your sign convention here, okay, and you've forgotten that the 9,8 needs to be negative, you're going to get that VI squared equals a negative value. That cannot happen. Okay, that means you have made a mistake, grade 12s, and you need to go and relook at it. Be very, very careful. So VI ends up being 4,20 meters per second, but it's a velocity, so it is upwards. Don't forget direction. It is a vector. Okay, so that wasn't too bad. And we go, okay, cool. We're doing okay so far. Same question still. Now they say to us, calculate the magnitude of the force exerted by the ground on the ball, okay, during the first bounce if the ball hits the ground at 6,27. Now, why did they give you that 6,27? If we go look back at 2.3 over here, 2.1, do you see I actually calculated that 6,27? But what if you had gone and had to use the equation where delta y equals vi delta t plus or half a delta t squared? You wouldn't have worked out that velocity, okay? So you wouldn't have that in your arsenal of information, okay? You wouldn't be able to use it. Also, what that means is if I had worked out something different here, okay, it's not a carry down error. Use the information given to you, please. Don't go and change that, okay? So what they're saying to you is over here at T1, that's 6,27, and now we've just worked out that it goes up at 4,20, okay? We want force exerted on the ground, on the ball during the first bounce if the ball strikes the ground at 6,27. So, there's something else missing here. The ball is in contact with the ground for 0.2 seconds. And I'm sure some of you are going, but Tracy, how did you know I was missing a piece of information? Because as soon as I'm looking at force exerted on the ground, F net delta T equals M delta V. There's a bounce, there's a contact, that means I have to use impulse. Okay, have to use impulse. Now, in order to use impulse, I needed to know time. You can't change sign convention, all right? Up is positive. So now watch. When the ball strikes the ground, it's going at minus 6,27. When it leaves the ground, it's going at 4,20. Okay? Very, very, very important. Also, along the way, right at the beginning, they told me that the ball has a mass of 0,5. So, Ft, F net, equals 0,2. Mass is 0,5. Final velocity, 4,2. Initial velocity, minus 6,27. Please, grade 12s, you cannot leave your negatives out. I know you want to, and I know it just feels easier, but please don't do it, because that becomes plus. If you don't put that negative in, you're going to end up with a negative value for this force, which doesn't make any sense, because if the ground has a negative force on the ball, somehow the ball's going to fall through the ground, okay, because up is positive. The ground must have a positive force on the ball, okay? So, what we get here, okay, and I'm going to show you this calculation. So we're going to go 4,2, and I'll show, actually let me show you on your calculator, you would do it. 0.5, okay, then I got my bracket, 4,2 minus, okay, minus, so we know it's negative, 6,27, close that bracket and that bracket, okay, and oh, we hate that little thingy, so this gives me F net 0,2, and it was exactly 5,385. Let's put the whole thing in. To get F net on its own, I'm going to divide both sides by 0,2. So I take my answer, divide by 0.2, and we get 26,92. Should we just, is my answer, sorry, I'm just getting a different answer to the one I prepared, which is never a good thing. Oh, no. 4,2 plus 6,27, there we go, times 0.5 equals, it's because I wrote it down wrong. Do you see that? That's not 385, that's 235. Wow. You know what? They might be reconsidering this position that I have.
No.
I would.
You're actually helping, because the matrix can go through their silly mistakes and see that they've made a mistake.
And then we get 26,175, but we round it off because we need 2 decimal places, so 26,18 newtons. Up. Okay. Oh, now we get to the next one, which you guys all go, sure, Tracy, whatever they want me to do. Sure. Okay, so draw a velocity time graph. For the motion of the ball from the time it is projected to the time when it rebounds to a height of 0.9. Guys, be careful here. That means of the graph, they only want it up to that point. Okay? They only want to see the first bounce. Okay? They only want to see the first bounce. Now we've got to remind ourselves, up is positive and we're throwing it down. Okay? So that means we are going to have a negative scale. And they say to clearly show the time when it hits the ground and the velocity of the ball when it hits the ground and the velocity of the ball when it rebounds from the ground. So, velocity time graph. It will have to have a negative side to it. Okay? This is velocity, so we have to have our okay, has to have units in it. Then we're going to go, okay, we have our units, and now we go fine. It came down, it started at -2, hit the ground at -6.27. When it rebounded, it came up and left the ground at 4.2. Okay. It hit the ground. We worked out that time at 0.44 seconds. Okay, we did that earlier. And then, listen carefully to me, it is in contact with the ground for 0.2 seconds, which means it actually leaves the ground at 0.64. Okay, so why is this important? Because starts at 0. At 0.44 seconds, it reached this velocity. At 0.64 seconds, it reached that velocity. Okay, so when I draw my graph, it is a straight line to there. Okay, because it's going down. Very, very important. Then it rebounds. Now it's going to come up. It starts here and then it ends up hitting the ground over here. And this line is a dotted line. Okay? We don't draw it as a straight line, but that's what they wanted. Okay? My two graphs on the side, they must be parallel. Okay? They should have a gradient of 9.8 because the gradient of velocity time graph is acceleration. Okay? You have a dotted line at an angle, and those are all the values we worked out from the graph. Do not draw anything else. Okay? You do not get extra marks for it, grade 12s. And in fact, sometimes, okay, if you draw extra stuff, so if you now carry on with this, they start taking marks off because you haven't listened, you haven't listened, you haven't heard the instruction, you haven't read the instruction properly. Okay, so you haven't actually answered the question, you've done your own thing. Be careful, okay? You all happy with that? So, Looney.
Yes.
Are there any questions, just quickly, that have come up specifically with this that you can recognize before we move on?
It is just question 1.4.2.
Just one. Okay, because I know I've gone really, really fast. I think what we're going to do, and I know it's a little early, but let's take a break now.
Okay.
And then the next question, you're going to breathe a sigh of relief. It's a little easier, I promise. Okay.
Okay, mindset is then you think I have a problem. You see? And then she says I'm crazy. But anyway, let's take a very quick break. And now she's going like this. And we'll see you straight after this, guys. Hi, guys. Welcome back.
Yes, and she actually really wants to be in musical theatre. Moving on.
One day.
Yeah. Okay, so guys, did anyone attempt to give me an answer to the challenge question?
Mandla said he was done, but then he never gave me an answer.
Mandla, you can't do that. I need an answer.
He said I'm done. Oh, actually, let me check here.
Yes.
Maybe Mandla gave us an answer, sorry.
Anyway.
Mandla said A is equal to
Yes.
3.5 meters per second.
Yes.
FT is equal to 182.5 newtons.
Okay, you got the first part right.
Can I read the other answers?
Well, the 3,53 is right for the acceleration.
3,5.
Yeah, that's fine.
Mm-hmm.
And for the, any others for the tension?
There's Sabelo with tension, which is 204. And then his acceleration is 10.6.
Ooh, you know
Okay.
that's faster than gravity. As soon as you get something faster than gravity, there's a problem.
Okay.
That's always a hint.
Okay, so then Rachilaya has acceleration which is 3.53.
Yes.
And then tension is 133.33.
There we go. She gets the thumbs up for the day.
Patrick also got that.
Brilliant.
And Junior also got 133.33 for tension,
Brilliant.
but 13.33 for acceleration.
Okay, I'm not sure you got that the other way around, but it's all right. It's fine. Guys, well done to the guys who got it right. Manda, I think you might have made a substitution problem in the an error in the second part of the question, but you got the acceleration right to start off with. That is all that matters. Okay, so let me just put that down. Okay, now let's go through this, and I'm going to show you quite an easy way of doing this, okay, guys? And I am going to have to go a little bit faster than we've done for the rest of the show, because we've gone quite slowly, apparently. It's okay. So, first thing we always need to do when we get a situation like this, and it's very similar to the first question we did, is separate your system out into two blocks. Okay, this is really, 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 really important, okay? So, you have the situation where you have A over here, and you have B. Now, why we separated is because the biggest mistake we make here is we go, well, the 200 newtons is affecting the B. Yes, it is, but not directly, okay? So what we're going to do is we're going to put, here's block A, okay? Block A has 200 newtons acting up on it, plus block A's gravity, plus Ft, okay? Now, Ft is a result of block B, okay? Now, I know block B's got weight. We're going to consider that next, okay? Block B has Ft pulling it up, which is because of A and the 200, and it has Fg pulling it down. Now we need to consider the fact that they said to us that this is accelerating upwards, okay, because it's accelerating in the force, in the direction of the 200, okay, and they don't tell you how far it's going accelerating, but it doesn't matter because we know it's accelerating upwards, okay. This is a Newton secondal question, which means we now go F net for both of these equals ma. Remember, the direction of the acceleration is the bigger force, okay, so whichever direction it's accelerating in, those forces are bigger. So the 200 minus Fg minus Ft equals mass times acceleration, okay? So we have 200 minus, now here, this is the 5 kilograms, so it's 5 times 9,8 minus Ft equal to 5 times A, okay? And 5 times 9,8 is 49. So I've got 200 minus 49 minus Ft equal to 5A. So 151 minus Ft equals 5A. And my platform is busy creaking quite nicely. Anyway, that is equation number 1. Now, guys, your teachers might have taught you to do this in different ways. In fact, it's another situation in my own school where a colleague and I, we get to this point, and from here we do something different, okay? It doesn't matter. The way I do it is a check, okay? So it's the way it helps you check whether you're on the right track. So that was for block A, okay? Now I'm just going to do another color because it makes it easier for you to see. So let's do block B. F net equals ma. Block B has Ft pulling it up, and its gravity pulling it down. Okay, so Ft minus, now in this case, not equal, minus 10 times 9,8 equals 10A. So Ft minus 98 equals 10A. This is equation 2. Okay, Now, what my colleague tells her learners to do is she likes to do this as a simultaneous equation, and she likes to do it by substitution. So in other words, what she does is she goes, well, ft equals 10a plus 98, and then substitutes it into this equation. I don't like doing that. Okay, it's a personal thing. What I prefer to do is I prefer to go, well, let's add these two equations together. Okay, this is just maths issue from here, because I'm going to solve for a. Watch. 151 minus ft equals 5a. Okay. ft minus 98 equals 10a. Now, the reason why I do this, grade 12s, is because, do you see, when I add these together, now remember, I now add constants together, variables together, all of that sort of stuff, okay? So I'm going to have 151 minus 98, which gives me 53, okay? Minus ft plus ft. My tensions cancel out. If my tensions cancel out, my equation has been set up correctly. If the tensions don't cancel out, then my equation hasn't been set up correctly. Then I know I've made a mistake. And this happens regardless of the number of blocks you have. So whether you have 10 blocks, 15 blocks, heaven forbid, I don't think they'll give you more than 3, but it doesn't matter because your tensions must cancel out. Because remember, one tension's pulling up, one part of the tension's pulling down. They're in opposite directions, which is why they must cancel. Okay? So this gives me 15a. That means I'm now going to go 53 divided by 15, and we get 3 comma, there's a funny line on my display. Let's not go there. I have no idea what that means, because it's,
What line?
over there. It's a new line.
Oh.
I don't know. Doesn't matter. I think maybe that means recurring. Who knows? Never seen that before. Moving on. 3,53. Doesn't matter. We've got to do it into 2 decimal places anyway. Okay? Now, do not put a direction. Okay? In this particular question, direction's fine because they were both grown up. But remember, sometimes they can be really mean, and if they do this on, and you've got a situation like that, say, remember that object's going to go down and that object's going to go sideways, so put a direction doesn't actually make sense, okay? So don't put a direction you don't need to. So that's the first one, okay? Some of you might have done it slightly differently. I've got a feeling some of you might have added the masses together straight away, okay? Which poses its own set of problems when you add the masses together in terms of gravity, but you know, there's lots of ways of doing this question. So you would have had 200 minus Fg, probably would have ended up with the same answer. That's fine, okay? Because they're going in the same direction, not a problem. However, if you added your masses together, that's where finding Ft in the next question becomes a problem, because you will get A equals 5,3. It just works for this particular question because of the nature of the question. But now I ask you to find Ft, which is why drawing these becomes really important, and having set up these equations becomes important. Now you can use either one of these equations, number 1 or number 2. I'm lazy, we all know this. I want to do it the easiest way, so I'm actually going to use number 2, okay? So watch what I'm going to do. So this is the second part of the, maybe I should have a pen, not an eraser. Number 2. Okay, I like all the pretty colors. Let's put this into equation 2. Okay, this is question 2, by the way. So equation 2 said to me that Ft minus 98 is 10 times A, which means Ft minus 98 is equal to 10 times 3,53. Okay, now if we do all the maths, that means Ft is equal to 35,3 plus 98, okay? And we end up with 133,3 newtons, okay? But I want to show you. If you put it into number 1, okay? So say you decide to use the first equation. It's up to you. So if I put it into equation 1 instead, Okay, which means I'm now got 151 minus ft equal to 5 times a, which means it's 151 minus ft equal to 5 times 3,53. I hate this because of the negative, but when you work this out, you get ft equal to 133,35. You get a slightly different answer. It doesn't matter, okay? It really, really, really doesn't matter. Though that answer doesn't look right either. 151, sorry, I'm pretty sure I've made a mistake there too. No, it's right. I have my moments. Anyway, it's always important. Stop laughing at me. Anyway, slightly different answer, doesn't matter, guys. It's taken into account. Okay, so probably Mandla, it was Mandla?
Yes.
You got tension wrong because you worked out your acceleration slightly
But do you
differently.
know what? Mandla says he's only in grade 11.
Even better, my boy. If you can do this in grade 11, you are
Well
A for
done.
away for next year, because this is based on grade 11 work, and it's why I used it as the challenge question. So Mandla, well done, because you've probably only just done it. And I'm telling you now, some of my learners, because now they're going to hate me, this was in their June exam, couldn't do it. Some of them are going to get slapped over the head, but shh, don't tell anyone. When I get back to school next term, because I'm a little upset with them. But it's okay. I think, though, guys, what we need, we didn't get through everything we wanted to do. Stay tuned, guys, because after this, there's a show on work, power, and energy. Really, really important for the grade 12s. You know that, okay? Grade 12s, do not neglect your grade 11 work. Okay, do not neglect Newton's laws of motion. Do not neglect Newton's law of universal gravitation, even though it wasn't in the exemplar per se. I think it was in some of the multiple choice. Do not leave it out, okay? It is very specifically going to get asked this year. Know it, practice, practice, practice. Okay.
Yes.
Over to you.
Practice, practice, practice. Matrix, wishing you all the best for those finals and for those prelims. Just to check score, Belgium, you are at 260 likes.
Only 260. Go Belgium.
Argentina is at 717. Switzerland is at 218. And the USA is at 455. So my team is ahead of yours.
Well, we'll see what happens tonight when Belgium kick USA's butt. Then we'll chat. Just saying.
Well, on Facebook. Let me just stick to Facebook, guys. We
Facebook.
are almost ahead. But guys, thank you so much for tuning in. We will see you very soon. Goodbye from us.